So in this video, we're going to talk about the idea of an E1 reaction and the basics surrounding E1 reactions. All right, so the E, again, no surprising, that stands for the elimination aspect of the reaction, and then 1 is the idea that it is unimolecular. So therefore, if we look at the rate law, we can say the rate is equal to some constant K times only the concentration of the alkyl halide. So let's look at a general E1 reaction. Now, typically for E1 reactions, we usually do these on tertiary alkyl halides. Now, the base in this case is usually also weak, right? So we do not use strong bases in E1 reactions. E2 reactions, we use strong bases. E1 reactions, there's usually no strong bases. So if you look at this molecule as an example, and we put this in some sort of base, well, the first thing that happens in an E1 reaction is that we form a carbocation. So it's similar to an SN1 reaction in that the first thing we do is form a carbocation. Now that is a slow step of the reaction, the formation of carbocation. So in this case, there's my carbocation. Here, I have a tertiary carbocation. Now, the next thing that happens in an E1 reaction is that the base now comes in and it takes off a hydrogen adjacent to the carbocation. Right? So in this case, it comes in, take a hydrogen that's adjacent to the carbocation. This now comes in and form a double bond. So the product of this reaction looks something like this. Now, we kind of spoke about the Zaitsev product and the Hoffman product before, and this is what we call the Zaitsev product. Again, I usually think of it as the double bond being in the middle. It is more substituted. So here I have one hydrogen and none on the opposite end. Now, remember that we could also have the Hoffman product, right? Now, the Zaitsev product is the major product. The Hoffman product, because these two hydrogens are also expendable, you would expect that only a small portion of this product would actually remain in solution. And this is what we call, again, the Hoffman product, or in other words, the minor product, right? It is less substituted. So this is what we call the Hoffman product. Now, let's look at another reaction. If you take this molecule and you put it in water. Now, I want you guys to keep this in mind. Water is special in that it can act as both a nucleophile and a base. Right? Now, we're looking at a tertiary alkyl halide. So immediately you really should rule out an SN1 reaction if you want to go there. I'm sorry, an SN2 reaction, because it just does not happen in tertiary alkyl halide. SN1 reaction, okay, maybe, but because they're nucleophile in this case, if you want to look at an SN1, the nucleophile is really weak. Water is a really weak nucleophile. So we'd expect this to go to an elimination reaction. Now the idea is this E1 or E2, again, the nucleophile is not really, the base is not really strong, so it wouldn't be E2. So we know this is an E1 reaction. And in this case, we can only get the Zaitsev product in this case. So the hydrogen is adjacent. So those are the hydrogens adjacent. So the first thing we do is form the carbocation. So this is an E1 reaction. So now there's my methyl group. Now I have a tertiary carbocation. Now water is going to come in and act as a base to form my double bond. So it comes in, acts as a base, take the hydrogen off, form the double bond. And this is where we get our product. And this would be our product. So that is the idea of an E1 reaction. Again, the base is not really strong, and we usually do it on a tertiary alkyl halide.